So with our notes, I would like to start off by the 3 that we did last time. So those should be the most familiar. And feel free to add or reword anything, because this is really for you. Okay, so holes, possibly plural. If I doubt we give you any that has more than one hole, that would be kind of tricky. These occur for x values that make both the numerator and the denominator zero. The key word in there that I emphasize every time I say it is both. So it made a big difference. And that just gave you the x value of the whole. The whole is a point. We also have to find the y value of the whole. And maybe phrase this a little differently than me. But to find the y value of the whole, you plug in the x value of the whole into the reduced fraction. If you don't know what notes you want to take, go ahead and start off with that. And come back and modify it so that it tailors to make the most sense for you. And we talked about vertical asymptotes last time. And these occur when and at x values that make only the denominator 0. Keyword only, because if it also made the numerator 0, it's no longer a vertical asymptote, it's a whole. You can't be doing more than one thing at a time. And these are vertical lines, so our answers for these always need to be a vertical equation. X equals some number. Number will change based on what function you want it to go to. And the other one that we did last time was x-intercepts. And these occur at x values and make only the numerator. Okay, keyword only. We also talked about why that is, because if you can make the numerator 0, that's when a fraction equals 0. And if our fraction equals 0, that's where y equals 0. And where y equals 0 is where you find its intercepts. So short of you thinking about that each and every time, because you need to know that, really just need to say, okay, the numbers meant only the numerator 0 is the next intercept, they meant only the denominator, so these are vertical spikes called vertical asymptotes. And if you made both, it's going to end up being a whole in the graph. So let's go ahead and answer those two questions, or these 3 questions for questions 1 and 2 down here, and then we'll talk about something new and try those out as well. So for all 3 of these, you need to know which numbers make the numerator and the denominator 0. So if something factors, you definitely want to factor it. 1 doesn't factor, so you can't do nothing with that. From here, I can factor out of 3. And then it's a trinomial that factors as an x plus 3 times an x minus 2. So I can see the numbers that make the numerator 0, and I can quickly see the numbers that make the denominator 0. 1 never equals 0, so nothing makes the numerator 0. 3 never equals 0. X plus 3 equals 0 at negative 3. And x minus 2 equals 0 at positive 2. So as long as I know those rules, I'm ready to write down 3 of the things that I need down here. There's no holes. There's no number that makes the numerator and denominator 0 at the same time. There's no x-intercepts, because there's no numbers that make the numerator 0. And there's 2 vertical asymptotes, because there's 2 numbers that make just the denominator 0. So x equals 2, and x equals 3. Negative 3, yes. So I did make these graphs a little bit bigger on the other pages. You can see it works a little crammed in here. But the copy machine does not like to copy these out very well, so I'm pretty sure you see those lines. So I can't plot, or I can't graph a hole if there's not one. And I can't label x-intercept if there's not one. But vertical asymptotes, we follow those vertical slices in the graph. And the way we're going to label these on our graph is by doing dash lines. So here's the vertical asymptote x equals 2. Here's the vertical asymptote x equals negative 3. I know it's going to spike here and spike here. It's going to shoot up to infinity on one side of that and shoot down to infinity on the other side of both of those. Okay, so let's head over and do the same 3 things for this particular graphic. I would also say one thing that's hard about this topic is sometimes it's hard to master finding the holes, the coordinates of the holes, because you might do 3 or 4 questions in a row that don't have a hole. And then it might be hard to practice doing vertical asymptotes, because you might do 2 or 3 questions that don't have vertical asymptotes. And every one of these questions can have everything. But this one's a little bit easier because it's already factored. I should already be able to tell you where the numerator equals 0 and where the denominator equals 0. No number makes both of them 0, which is how you get a hole. One number makes only the numerator 0, which is how you get an x-intercept. And of course, we can put that on our graph. And one number makes only the denominator 0, which is a vertical asymptote, which we show as a vertical asymptote. So that line is going to spike up to infinity on one of these sides and down to negative infinity on the other side. I don't know which one yet. Okay, so to understand what's going on in these graphs, I need to also be able to answer some of this other information. N asymptotes, horizontal asymptotes, x-intercept or y-intercepts, and then potentially even just try to plug in a few values. Okay, so thank you last class, but try to make sure that you really understood that so that this would be less of a focus for you today. I would say the next easiest, well, probably the easiest of all of these is y-intercept. And all y-intercepts occur when x equals 0. So, plug 0 in for x and solve for y. So it's no coincidence when we did the linear stuff last semester, I always tried to phrase it to you the same, not because I thought that was the only way to get the answer in the linear unit, but because it transfers over exactly the same amount of y-intercepts. Okay, so let's answer questions 1 and 2 for y-intercept. If y-intercept is when x is 0, and you can only have one y-intercept, and you just go and you plug in 0 for x everywhere that you can, and this one you get 1 divided by 0 plus 0 minus 18. So 1 over negative 18. Very, very close to 0 on the negative side. So add that point to your graph. Plug in 0 for number 2. You get negative 2 on top, negative 4 on the bottom. That reduces to 1/2. So when x is 0, y is 1/2. It's like you're plugging in any point for, like you're making a table, which we need to do a little bit of. But you're specifically plugging in 0 because that's where the y-intercept's going to occur. Very, very easy to compute. Notice I didn't even have to write anything down. I can do that everything. I'd say maybe the next one that makes sense would be horizontal asymptotes. And to find a horizontal asymptote that has one, or where's it at, you have to compare the degree of the numerator to the degree of the denominator. And that gives us 3 situations that could happen. Because the degree of the numerator could be bigger, the degree of the denominator could be bigger, or they could be equal. After we practice this one for a minute, I will give you a moment to go back and adjust your notes and add stuff to them and reword them so that they're more useful to you. But first, let's say that the degree of the numerator is bigger than the degree of the denominator. In that case, you have no horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. And if the degrees are equal, the degree of the numerator equal to the degree of the denominator, it will be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So as far as applying these questions, it's usually easy because it takes very, very little work, or the step or two that you have to do is all in your head. But at the same time, until you know these rules, there's really not any other way that you can go about figuring those out. So let's try this on questions 1 and 2, and then I will pause for a moment and let you go back and adjust your notes so that you can come up with your problems. Okay, so if I look at question 1, the degree of the numerator is 0 because there's no x's up here, and the degree of the denominator is 2. So in this case, if the degree of the denominator is bigger, horizontal asymptote will be y equals 0. I'm not taking any special shortcuts there. It's just that I know those rules. The degree of the denominator is bigger, so it's y equals 0. And just like vertical asymptotes, we graph the dashed lines, you do the same thing with horizontal asymptotes. To add another flashback to that later, you graph vertical lines and horizontal lines partly for stuff like this. Okay, question 2, the degree of the numerator is 1, the degree of the denominator is 1, so the degrees are equal. If the degrees are equal, you have to take the leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator, which is 1. So you get y equals 1 over 1, or just 0. And graph that as a dashed line. Before we do the last couple, what I suggested you write for holes, vertical asymptote, horizontal asymptotes, x and y intercepts, and see if you want to add some information here or reword it to a way that makes sense to me, doesn't make sense to you. Now would be a great time to do that. So I'll give you a moment to see if you want to make some changes here. Okay, so next up, how and when to find a slant asymptote. And I think most people in America call it a slant asymptote, but most of the rest of the world I think refer to it as an oblique asymptote. Sometimes on like trivia questions or math contest questions, they say oblique asymptote, but same thing, slant asymptote. You definitely don't want to try to find slant asymptote if you don't have to, because it's going to require long division. You want to know when to even bother. A rational function will only have a slant asymptote when the degree of the numerator is exactly 1 bigger than the degree of the denominator. So if that's not true, just say that there's not one and move on. Which is going to be the case most of the time. Most rational functions don't have a slant asymptote. But when that is true, how you're going to find it is it's going to be y equals, the equation below. It's going to be y equals the quotient but not the remainder from long division. So if something has a remainder, it just has no effect on the slant asymptote. We get to ignore it. Y equals whatever the quotient ends up being. So we're going to go through a whole bunch of methods. Hopefully question 3 has one. Question 1, the degree of the numerator is 0, the degree of the denominator is 2, so the degree of the numerator is not 1 bigger than the degree of the denominator, so don't do long division there. Number 2, the degree of the numerator is not 1 bigger than the degree of the denominator, so there's not a sign asymptote. I can do that. So again, I'm going to work question 3 for you all at once. And if it doesn't have a sign asymptote, I'll just try to find one that does so we can see what's better. Alright, and then finally, the last piece, domain. This is the same domain we did like the first couple weeks of school. Domain is asking what x values can be plugged in to the equation. What x values can you plug in? The thing is, you can plug in just about anything you want to. So we don't dare just try to list out everything possible. Instead, figure out what we can't plug in. And there's two types of numbers that you can't plug in for domain. Domain refers to real numbers, so we don't want to take the square root of negative numbers for domain, but we're not going to be looking at any square root stuff today. And 2, you can't divide by 0. It's not possible to divide by 0. So domain could care less whether you're dividing by 0 and getting a whole, or dividing by 0 and getting a vertical asymptote. Domain just cares that, hey, you can't have that number. That number is not going to exist on the graph. That x value is not going to exist on the graph. Okay. And we need to write those in interval notation. Okay, so down here, we said, again, I could care less whether it was a whole or a vertical asymptote, but I could not plug in 2, and I could not plug in -3. So I had suggested to you, beginning of the year, to get a number line and say, all right, I can hit all the x values I want, but I'm going to have to pass over -3, I'm going to have to pass over +2. Because this gives you a visual, you can hit all of these, which is -infinity to -3. You can hit all of these, which is -3 to 2. And you can hit all of those, which is 2 to infinity. Make that little number line there. It's easier to see how to write those. This is giving me this. This is giving me this. And this is giving me that. So even if I wanted to list them all out, I couldn't because there's infinitely many. There's infinitely many numbers even just between -3 and 2 because they're all in decimals. So we have to give a range of values. All the numbers here, all the numbers here, and all the numbers here. It's a very fancy way to say not -3 because we're taking the numbers less than it and more than it, and not +2 because we're taking the numbers less than that and more than that. And you can put commas here if you want to, but most tests, and I would assume the ACT, are going to put U's here, which is a symbol for union. It's just a different way to say and. So I'm probably going to have it put the union symbol just so you're used to seeing it. Okay, so over here, the only number that made me divide by 0 was 4. So I can plug in any x value I want except for 4. So that means I can plug in x values from -infinity to 4 and 4 to infinity. Alright, finally, let's figure out what the rest of this graph looks like. And take it with their calculators and move on. So I probably could put together this graph right now because I know a few different things about it. This one, though, I don't think there's enough information here. I probably need to find some additional points. So there's not really any limit on how many or how few that you should get, but don't plug in hard stuff. Don't plug in where 50 or x is 50. This is going to be too hard to compute without a computer. Plug in maybe when x is 1. I plug in 1, shouldn't need a calculator for that. That would give me 1 over 3 plus 3 minus 18. So it would be 1 over 6 minus 18, which is negative 1/12. Okay, so is negative 1/12 bigger or smaller than negative 1/18? Negative 1/18 is a decimal. The fraction is bigger, but because it's negative, it's a smaller number. So that means it's still super tiny, but it's a little further down than this one is. Okay, so believe it or not, I am very ready to put it in the graph now. Doesn't look like we have much information, but what's going to happen is I know how this graph is moving. I know this one's a little bit lower than that one. And now that I know the direction of this graph, I know how it interacts with this vertical asymptote. Remember I said it spikes up on one side and spikes down on one side? Well, if this graph is heading this way, this tells me it's going to spike down to negative infinity on that side, which means it's going to have to spike up to positive infinity on that side. And based on the direction of this graph, I know this is going to go this way. And so another vertical asymptote, so it's either going to have to spike up or spike down. But based on the way I know the graph's going, let's say this is going to spike up on this side, which means it's going to come to negative infinity on the other side. And at the ends of the graph, the horizontal asymptote behaves the same way. It gets close to that line but can't cross it on the end. It can cross it in the middle. And over here, it gets close to that line but doesn't cross it. Now, that's not going to be 100% perfect. The only way I could do that is if I was willing to plug in all of these x values, which is basically what your calculator does. And you might want to change the window settings to negative 5 to 5 because that's what we have. And I flipped that one wrong. Okay, so here was my assumption that I was wrong about that. I assumed that this was going up this way because of this direction, but I guess I was wrong. I should have forced myself to plug in another point here, like negative 1. So let's make so if I had plugged in negative 1, I would have seen this was actually going this direction, and if it shoots down on this side, then it shoots up on this side. So it's a little steeper than I drew in my curves. These kind of like these asymptotes a little bit more, but that's fine. Okay, this one is also almost very close to being done. Anytime you have two vertical asymptotes, it gets a lot more complicated like that. With these, I already know these 2 points, so I can see that they're going to be connected. Since I see the graphs going down as I go to the right, as I get close to this vertical asymptote, it's going to have to shoot down to negative infinity. And if it shoots down to negative infinity on the left, it's going to have to shoot up to positive infinity on the right. And then I've got the ends of the graph, so now I can take this horizontal asymptote. The line will get close to the horizontal asymptote, but not cross it. And the line gets close to the horizontal asymptote, but doesn't cross it. And notice, I didn't even need to plug in any more points that time. Give me exact accuracy, so I can see this is up here. You know, I was a little liberal with how much of it showed on the graph here. But you can tell that everything looks fine. So now let's look at one. There's a little more factoring, but all the same rules still. Also notice from the first 2 questions that question 1 felt a little cramped in here. Question 2 felt like I had plenty of room, especially since I didn't plug in more points. But I did try to give you a bunch of space for some of these, especially if something has a asymptote. You need the room to do a long division sometimes. So. Alright, so what you think is easy, what your neighbor thinks is easy is probably completely different. So, in the moment when I have you practice one, you need to think about which of these skills you think are the easiest. And completely understandable that you don't feel like you have all those mastered today. But I personally like y-intercepts. Y-intercepts are very easy. And so the part that you have to memorize is that you plug in 0 for x and solve for y. So that gives me 0, minus 0, minus 0, divided by 0, minus 0, plus 18. 0 divided by 18, 0. There's 1 point on my graph. For x-intercepts, poles, and vertical asymptotes, I have to think about what numbers make the numerator 0 and what numbers make the denominator 0. So, if it's not factored, you got to do that. You take out an x. And factor its number. I've got a negative 3. Factor its number. Even though this is a lot of work, it helps us with 3 of those things. So. Now I can see the numerator equals 0 at 0, 3, and negative 2. The denominator equals 0, well, negative 3 equals 0. This equals 0 at negative 3, and this equals 0 at positive 2. And again, once you've had time to absorb all the different rules, you're ready to write out the next few answers. What number makes the numerator and denominator 0? Which is what? 3 as a whole. There's 3 numbers that make just the numerator 0. So this is going to have 3 x-intercepts. And there's 2 numbers that make just the denominator 0. So those will be vertical asymptotes. It's nice that there's not much work to get the answer. The trade-off is you have to know this. You have to have more stuff memorized. So I need to plot these. Well, 0, 0, I already knew. The origin is not just an x-intercept, it's also a y-intercept. So that would be problematic if I didn't get it there. Also this point, vertical asymptotes. Not really part of the graph, but we indicate those with dash lines. Horizontal asymptotes, we have to compare the degree of the numerator to the degree of the denominator. The degree of the numerator is bigger, it doesn't have one. The degree of the denominator is bigger, it's y equals 0. And if the degrees are equal, we have to do the leading coefficient of the leading coefficient. In this case, the degree of the numerator is bigger than the degree of the denominator. So no horizontal asymptote. I'm not taking any special shortcuts, I just know the rules, which is what you need to eventually do. For slant asymptotes, I only want to do that if the degree of the numerator is 1 bigger than the degree of the denominator, which is true here. So this will have a slant asymptote. And for us to find it, we have to do long division. And we need to ignore the remainder. Okay, so I have to ask myself, I'm going to do this in 2 parts. I have to ask myself, how many x's times x squared gives me x cubed? I'm needing x squared. X times x squared gives me x cubed. And this is an understood 1, so I have to ask myself, what times negative 3 gives me 1? And that would be negative 1/3. Negative times a negative is positive. 3 times a third is 1. So that this is the same. And then we have to multiply to this 2, which would be positive x squared. And then multiply to here 2, which would be negative 6x. Switch the signs. Add. Those were supposed to go away. These also end up going away this time. And a negative x squared minus an x squared gives us a negative 2x squared. So it looks like we could go one more time, because something times negative 3x squared gives me negative 2x squared. Now, any x's, I don't need any x's here, but I have to ask myself, what times negative 3 gives me negative 2? So I want this to be positive, because a positive times a negative is what gives me a negative. And then it would be 2/3. Putting this over 3 would cancel out this 3. Putting a 2 gives me the 2 that I want. So 2/3 times negative 3x squared would be negative 2x squared. So I'm choosing to put that there. And then this times this would be negative 2x. This times this would be, so it's like dividing by 3 and times it by 2. That's how I'm doing that so quickly. This would be 6 times 2 is 12. And I'm going kind of quickly on this part because I can see that this is going to end up being the remainder anyway. And for slant asymptote, you could care less about the remainder. So even if I made a very careless mistake right here at the end, it's not even going to transfer over. The quotient only ends up being the slant asymptote. And we can graph that. This is mx plus b. The y-intercept is 2/3. The slope is down 1, right 3. 1, 2. But this is also an asymptote, So we don't want to draw this one as a solid line, as it means part of our graph. We can just draw in the graph. All asymptotes have a dash line. Okay, many of them have a sign asymptote. So probably most important is to know why I'm doing that on this question and not the first two. Neither is a sign asymptote because the degree of the numerator was one bigger than the degree of the denominator. If that's not true, then don't bother with this. If it is true, then you have to do that. Domain is asking me what values can I plug in for x. So I'm not worried about any square root stuff. I'm only worried about division by 0. I don't care whether -3 and 2 are vertical asymptotes or poles. I just know that I can plug them in. So I can plug in any x value I want. But we better make sure we skip -3 and +2. So I can plug in all of these x values. I can plug in all of these x values. And I can plug in all of those x values. A lot easier if you give yourself a visual. Alright, occasionally we need some extra points to figure out what's going on with our graph here. I definitely needed extra points on question 1. I needed at least one more than I did for myself. I assumed too much too early. In question 2, I didn't need any additional points. These points that I got up here, along with those vertical asymptotes that I had, horizontal asymptotes and sign asymptotes, was enough information. This question, I think, was enough information. So, the ends of the graph of a slant asymptote are going to behave just like a horizontal asymptote. It can't cross this graph at the ends of the graph. Vertical asymptotes, it can't cross at all. But the fact that I see these 2 points means I know that these are going to be connected. I put a little bit of arch here because if it's going this direction, well, yeah, I guess I better plug in at least one more point, I guess. Let's plug in when x is 1. I'm going to figure out what's going on here. If I plug in 1, I get 1 minus 1 minus 6 over -3 minus 3 plus 18. Okay, 1 just gives us easy to evaluate. Okay, so that's what I was assuming, but that's a little caution because of what happened in the first question. So now I know when x is 1, y is -1/2. So now I am sure about this direction. And so, based on going this way, and how it has to behave with this vertical asymptote, it's going to shoot down on the left side, so up on the right side. Based on this direction, it looks like it's shooting down on this side, which means it has to shoot up on this side. I also know this point is an x-intercept, so I can go ahead and connect that in. And you can't cross the slant asymptote at the end of the graph. So it's kind of coming close to it, and it can hook up to it, but it can't cross it. Same over here. This is shooting up, and so it's coming down, but it's got to kind of turn a bit because it can't cross this slant asymptote at the end of the graph. More points are always going to be better, more accurate. But usually just a few points is enough to determine the direction of the graph. because we understand how vectors and asymptotes. Okay, so what I'd like you to do on question 4 is I'm going to work all of question 4 for you. And of these 2, 4, 6, 7 different things, I would like you to try to answer 4 of them. So whichever 4 of those 7 things you think are the easiest, do those and make sure that you're actually accurate with those. And since you're picking the easiest ones, you should try to flip back to your notes a little bit less right now. Figure out 4 of them at some point, flip over and look at your notes. So let's go over all of the practical putting graph, and you can check off the ones, make sure that you are doing the ones that you actually do correctly, otherwise that should be a warning sign. And then also hear an explanation for the other ones that you thought were not going to be easy. So just from past experience, usually y-intercept is one of the first things that people do, because plugging in 0 for x makes almost all of this go to 0. You get 0 plus 0 minus 6 over 0 minus 0 minus 12. Negative 6 over negative 12 is 1 half. Add that to your graph. For x-intercepts, holes, and vertical asymptotes, you need to know what numbers make the numerator 0 and what numbers make the denominator 0. So the numerator is just a straight trinomial that you've seen a couple times, what it looks like, or very similar, I guess. And the denominator, you should have factored by the negative 4 first. And then factor it as x plus 3 and x plus 1. So, all of that was to figure out that 2 and negative 3 make the numerator 0, negative 3 and negative 1 make the denominator 0, and so there is a number that makes the numerator and denominator 0. That ends up being the x value of the whole. There's a number that makes just the numerator 0. That ends up being an x-intercept. Plot that on your graph. There is a number that makes just the denominator 0. So that ends up being a vertical asymptote. And we can put that on our graph as a dashed line. Okay, so again, this is one that people usually look back at because you don't get to practice it very often. Most rational functions don't have holes, but when they do, we need to be able to find the y value too. So this is where if negative 3 made the numerator and denominator 0, there must have been a factor of x plus 3 in the numerator and denominator. You have to plug in negative 3 into the leftover stuff. So that would be negative 3 minus 2 on top. And a negative 4 times a negative 2 in the bottom. Negative 5/8. So that's the location of the hole. Now you can't really draw the hole on the graph because it doesn't exist there. So what we do instead is we put a big open circle there. When x is negative 3, y is negative 5/8. 4/8 would be a half, so 5/8 is a little bit less than negative 5/8 is a little bit less. So, open circle to show where the hole is. Okay, for a final asymptote, you had to compare the degree of the numerator to the degree of the denominator, and because they are equal, you should have done y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Y equals negative 1/4. It's an asymptote, so graph it as a dash line. Y equals negative 1/4. An asymptote would have been a very easy one for you to check off because the degree of the numerator is not one bigger than the degree of the denominator, so you could at least know that there's not completely. The domain should include everything except for negative 3 and negative 1. And I don't care that negative 3 is a whole. I don't care that negative 1 is a vertical asymptote. I just know I can't plug those values in. The domain doesn't care about why you plug it in, just that you can't plug it in. So all of these would be written like that. All of these would be written like this. And all of these would be written like that. There's 3 sections of numbers, 3 ranges of values that we can plug in. Sometimes we need to do additional points to get the graph, but I think you actually have enough information here. Now on the test, I mean, you probably do like 2 or 3 of these on the test, where they ask you every single part of one of these functions. So on the test, I don't know, I'd recommend that you plug in as many points as you feel like you can without a calculator. We wouldn't give you a calculator because we don't want you to just graph and look at a lot of this stuff and write it down without that. But the fact that these 2 on my graph, I know those are going to get connected. And I can see the graph is going up as I go to the left. So this vertical asymptote must shoot to the right on this side, or up on this side, and down on that side. And this hole, even though it doesn't seem very helpful, it will still hit all the points right before it and right after it. It just misses that one instance. And at the ends of the graph, my graph will get close to that horizontal asymptote, but not cross it. Close, but not cross it. And then the ultimate check is, if all of that is correct, then the calculator's graph should look like correct. We put the vertical asymptotes in the wrong spot, or said there was a hole when there wasn't, it throws off the graph. And it's pretty obvious that something wrong. Quick 5-second sketch, if it looks the same, then all that's probably good. I'd like to do one more like that, where I give you a chance to practice some of it first, and I still go over it. So, do that with question 5, please. And to make sure that you don't do all this work for nothing, notice this negative sign. You might want to move this negative sign up here next to the 4 so you don't lose it. So I don't expect you to have all of these things mastered, but you need to start making some improvements. However many that you were able to do on the last question, try to do that or better on this question. Go back to the front page and pick me up as you need to. So when you look at this note, try to remember the note. That's ultimately what you have to do. sure you can use the numerator. So let's go ahead and check it. Okay. Now, understandably, you will find to be frustrating. Do you need to ask the next 3 classes about vertical asymptotes or horizontal asymptotes? How do I know that that's the answer? Unfortunately, you basically didn't have to say what you wrote down on the front page because it just doesn't change. You have to ask me, how did I know that the horizontal asymptote at y is 0? All I can say is because the degree of the denominator is bigger than the degree of the numerator. If you can't memorize that, then there's no other tip I can give you there. If you ask, how do I know that there's a vertical asymptote at x equals 0 and x equals 3, I would say because 0 and 3 make the denominator 0, but not the numerator, because nothing makes the numerator 0. For x-intercepts, there's no number that makes just the numerator 0, so I know that there's not one. For wholes, there's no number that makes the numerator and the denominator 0, so I know there's not one. For domains, I know I should be skipping 0 and 3, but I have to include everything else, so that's how it's written out. For intercepts, you plug in 0 for x and solve for y, but you get -4 divided by 0, which you can't do. So that one's not possible, which is consistent with this. There's a vertical asymptote at x equals 0. It doesn't get to hit an x value of 0, which is what a y-intercept is. And I know, without any work really, that there's no slant asymptote because the degree of the numerator is not 1 bigger than the degree of the denominator. I'm not doing any cheats there, it's just I know the rules. And all that stuff and can apply it quickly and do it well. As far as the graph's concerned, all asymptotes go in as dashed lines. Any points we know we can label. And we really don't have any points, I guess. There's no x-intercept, there's not a y-intercept. So this is not enough for me to sketch in my graph like it has been on the last few questions. I need to plug in some other values. So I'll plug in 20 for x. That's going to be harder to compute. Don't plug in 0 for x. You should know you can't plug in 0. You see that already. Plug in 1 maybe. You get -4 over 1 minus 3. That's not too hard to compute. Add it to your graph. You try to plug in 2. 4 minus 6. Also 2. Maybe try to plug in -1. It's -4 over 1 plus 3, which would be -1. Okay, maybe you could pick some points in it. Doesn't matter. Maybe you want to pick more points to feel more confident about your graph. That's great too. But at some point, if you know how to respond to these asymptotes, you should be ready to start to sketch again. This was a horizontal asymptote, so it can't cross it on the ends of my graph. That's on that. If it's going this direction and there's a vertical asymptote here, it's kind of like a brick wall, it's not going to be able to go through it. So it shoots down right there. If it goes down to negative infinity on the left side, it's going to go up to positive infinity on the right side. And down to hit this point that I know it hits. Also like in this point, so I don't know exactly how much of it is here. I'm just going to do a bit of a guess. But there's another vertical asymptote, so it's got to shoot up to avoid hitting it again. And if it shoots up on this side, it's going to shoot down on this side. So now I know the direction over here. And again, just like can't cross the horizontal asymptote on the left end of the graph, can't cross the horizontal asymptote on the right end of the graph. So it's going to put close to it, but not cross it. So I had to plug in at least a couple more points before I felt like I knew what was going on. Sometimes you do, sometimes you don't. But as you practice these, if your graph doesn't end up looking like your calculator's graph, then something's going on. And it should give you a what's off. So what I'd like you to do is question 6. You're going to be on your own. Go back and forth to your notes all that you need to. Try your methods, work with your neighbor. Graph in the calculator when you're absolutely think that you're done and you're ready to check it.